So in the previous class, we discussed up to question number 42, and in this class we discussed from question number 43. So the question is, if T1 and T2 are dry bulb temperature of air entering and leaving the coil, and T3 is the apparent dew point temperature of the cooling coil, then T1 bypass factor of the sensible cooling of the air. This is T3 and this is point 1 and point 2. So the apparent dew point temperature is T2 minus T3 divided by whole T1 and T2. Sensible cooling, that means their temperature increase, and T1 is greater than T2 and T2 is greater than T3. So this region is the bypass factor. So T2 minus T3 divided by T1 minus T3 is the bypass factor. So option C is the correct answer. Next, during mixing of steam in case of air conditioning process associated with. So the during mixing is adiabatic mixing. Next, the presence of moisture in the refrigeration effect is felt at expansion valve. The humidity ratio is also expressed as the PS. PS is the partial pressure at superheated vapor, and P is the barometric pressure. So this is the formula based, and the formula is 0.622 PS by E minus PS. Next question number 7. If you have 100% relative humidity RH, then dry point temperature and wet bulb temperature and dew point temperature and wet bulb temperature and dry bulb temperature can be related as 100% relative humidity. That means dry bulb temperature, dew point temperature and wet bulb temperature all are equal. Option B is the correct answer. Next question number 48. The desuperheating coil in a condenser perform the function of desuperheating in coil and condenser perform improving the condenser performance. Option C is the correct answer. Next question number 49. In split system air conditioner, the condensing unit is located. Condensing unit is located outside the area of condenser. So the condensing, that means condenser is present outside the area of the condenser. Next question number 50. Refrigeration R717 represent. R717 represent. This is R700 series, that means R707, the molecular weight of 7. So NH3 ammonia, molecular weight is nitrogen is 14 and hydrogen 1 into 3 is 3 times, it is 17. So R700 plus 7, that means 707. This is the R707, that means ammonia. So option C is the correct answer. Next, the maximum thickness of boundary layer in case of a pipe of radius R. The maximum thickness is option A. Next question number 52. How does pressure intensity varies when liquid rotate an angular velocity of a vertical axis? So this is directly with the square of the radial distance. Option B is the correct answer. Next, pitot tube is the measurement of. Pitot tube is measure for velocity. This is the time layer and this is the pitot tube, where this is the stagnation point where velocity 0, and by measuring the pressure we can measure the, by measuring the height we can measure the velocity of the fluid. Next question number 54. The hydraulic mean depth of circular pipe of diameter d running full equal to. So the hydraulic depth of circular pipe is d by 4. Next, in order to increase the sensitivity of U2 manometer, angle theta and sensitivity is 1 by sin theta. Option D is the correct answer. This is also formula. And the Euler equation is uh, dp by rho plus v dv g dz is equal to 0. Next, for a dimensional analysis, the Buckingham pi theorem finds the resulting equation. Then n minus m represent the parameter. N minus m dimensionless parameter. So option A is the correct answer. Ratio of inertia force to surface tension. This is Weber number. Next, question number 59. SI unit of viscosity. So viscosity, shear stress that is proportional to mu du by dy, and this is the viscosity. So the CGS unit 10 poise is equal to Newton meter per second square. That means 10 poise is equal to SI unit. Just a minute. So 10 poise is equal to 1 Newton second per meter square. So 1 Newton second meter square is equal to the unit of dynamic viscosity, and this is equal to 10 poise, which is equal to the SI unit. So 10 poise is equal to the answer. Next, question number 60. For a liquid coming out a nozzle, the maximum height attained by u square sin square theta divided by 2g. Next, the equation of continuity is applicable when the flow is steady, one-dimensional, velocity is uniform at all the sections. So option D is the correct answer, all of the above. Cavitation is caused when pressure is low pressure. Next, question number 63. The center of buoyancy is centered of the displaced volume of fluid. Option A is the correct answer. Next, question number 64. All term of energy in Bernoulli equation have. So Bernoulli equation is P by rho g plus V square by 2g plus z. Z unit from the parameter z, we can unit meter. So meter represents the distance, that means length. So all the energy parameter given the dimension of length. Head loss at the entrance of the pipe. So head loss at the entrance of the pipe is 0.5 V square by 2g, and at the exit, so head loss is V square by 2g. This is exit head loss. Next, separation flow occur when pressure gradient. Pressure gradient is dp by dx is less than 0. So dp is equal to p2 minus p1 divided by change in length is negative. And this is the flow nozzle. This is 0.1 and this is 0.2. P2 minus P1, this is 0.2 and this is 0.1. P2 minus P1 is negative when P1 is greater than P2. So this is 0.2 and this is 0.1. Just a minute, we have to erase it. And the flow separation will occur in the diverging section. This is converging section and this is diverging section, and this is 0.2 and this is, sorry, this is 0.1. P2 minus P1 is negative when P1 is greater than P2. So this pressure is greater than P2, that means flow will flow towards the this point. So this will be flow separation is occur. So 66 answer will be less than 0. Next question number 67. Drag force on a body result to a component of resultant fluid dynamic force in the flow direction. Question number 67 answer will be B. Next question number 68. Sonic velocity for adiabatic mentioners C is equal to gamma RT root over of option A is the correct answer. Next, the magnitude of velocity at the stagnation point is immersed body. Stagnation point at we discussed from the previous question. Stagnation point velocity is 0. So 69 option A is the correct answer. Next, in two-dimensional velocity field with velocity u and v are in the x and y direction respectively, the convective acceleration along the x direction. So the convective acceleration is u du by dx plus v into du by dy. So u du by dx plus v du by dy. Option D is the correct answer. This is convective acceleration, and if you add du by dt, sorry, du by dt, and this is local acceleration. Next, Curtis turbine is velocity compounded impulse turbine. Option D is the correct answer. Next, for maximum blade efficiency for a single stage impulse steam turbine with nozzle angle alpha, then the rho is equal to u by v, which is equal to cos alpha by 2. Option C is the correct answer. Just a minute. So next question number 73. Steam flow in a steam generator is controlled by, and then steam flow sensor. Option C is the correct answer. Next, 74. In a steam turbine, the reheat factor increases with increasing number of stretch. Option A is the answer. Next question number 75. Just a minute. Which of the following indicate the correct order in the path of flue gas? So the correct order of flue gas path is superheater, economizer, and then air preheater. Option A is the correct answer. Next question number 76. In a centrifugal pump casing, the flow of water leaving the impeller is. So in the centrifugal pump, the inlet is axial and exit it radial. So the answer will be option B, radial flow. The question is asking leaving the impeller, so radial flow leaving from water of the water. Next question number 77. If T is the diameter of impeller at inlet with width is W of the impeller at the inlet and Vf is the velocity of flow at the inlet, then the discharge through the centrifugal pump. So discharge will be by d V velocity in the width. So option C is the correct answer. Next question number 78. When a centrifugal pump is started with there will be no flow of water until pressure rise in the impeller of large enough to overcome. The answer will be manometric head. Next, the specific speed of a turbine is indicated by. Specific speed of a turbine is indicated by. This is just a formula we have to remember. N root over of P by H power 5 by 4. Option B is the correct answer. And N root over Q divided by H by 3 for NS for pump, centrifugal pump. You have to remember n root over q divided by h power 3 by 4. It is for pump. And option B, which is n root over p h by 5 by 4, which is specific speed for turbine. And this is for pump. This is very important question. Next, question number 79 is done. Next, question number 80. If alpha is the angle of blade tip at outlet, then the maximum hydraulic efficiency. Just a formula. We have to remember 1 plus cos alpha divided by 2. Option A is the correct answer. Next, question number 81. In a reaction turbine, it is not exposed to atmosphere. Option D is the correct answer. Next, question number 82. In a reaction turbine, the draft tube is used for to convert the kinetic energy to flow energy by gradual expansion of flow cross section. Option B is the correct answer. This is the purpose of draft tube. Next, question number 83. Which of the following is not a rotary pump? Gear, van, axial, and screw. So axial is the not a rotary pump. This is rotary. Rotary are gear, van, and lobe type, and screw type. So gear, van, screw type, and lobe are rotary, and axial are not a rotary. This is our reciprocative type pump. So air vessel are used in reciprocating pump are initially filled with water, vacuum, compress. None of these. Next, question 85. A plot between power generated in megawatt and time is known as. This is known as load curve. This is power versus time curve is known as load curve. Then question number 86. The ratio of maximum load to rated plant capacity. This is known as maximum load to rated capacity is known as utilization factor. Next, question number 87. Capacity of hydroelectric plant in service in excess of peak load is known as. This is known as cold reserve. Next, question number 88. In a Pelton wheel, the bucket peripheral speed is 10 meter per second, water jet velocity is 25 meter per second, and volumetric flow rate of the jet is 1 meter cube per second. And if the jet deflection angle is 120 degree and the flow ideal, the power developed. So we know the power developed is rho q b minus u 1 plus cos phi into u. So density is 10 to the power 3 as the working fluid is water, and density is 10 to the power 3 kg per meter cube, and q flow rate is 1 meter cube per second, and velocity is given, jet velocity is 25, and the peripheral speed, that means bucket speed is 10, and 1 plus deflection angle is 120. That means the angle which deflected is related to the x-axis, which is equal to 180 minus 20 is equal to 60 degree, and u given, that means 20 10, that means bucket speed is equal to 10. So after calculating we get 22.5 kilowatt. Option B is the correct answer. Next, question number 89. NPSS, a net positive suction head of a pump is not obeyed, then pump get cavitated. For the prevention of cavitation, we require NPSS, net positive suction head. Next, the last question. A hydraulic turbine generated 500 kilowatt at 1500 rpm under the head of 60 meter. During testing condition, a scale of model 1.5 work under the head of 15 meter. The power generated by the model will be. So we have to solve this. This is the prototype, and this is the model. This is symbol P, and this is model. So given data, so hydraulic turbine generated 500 kilowatt and 1500 rpm and head 60 meter. This is prototype. So the speed is np is equal to 1500 rpm, and head is given 60 meter, and power of prototype given 500 kilowatt. And here the scale ratio, that means 1:5 under the head of 15 meter, that means model head is 15 meter, so head of model is 15 meter, and the scale ratio, that means diameter of prototype divided by diameter of model is 5. So the we know formula for nd root over of h is equal to constant, so equal to we get, and dp is equal to 5 times of dm. So n of model into d of model divided by root over of h of model is equal to n of prototype and d of prototype divided by root of h of prototype. So putting all the value nm we have to found, and dm, and model height is 15 over 15 is equal to np given 1500, and dp is 5 dm, so dm cancel, and root over hp given 60 meter. So we calculated model rpm, that model speed is equal to this 16 divided by this 15 root over 15 divided by 16, 1 by 4 is 1 to 750, 750 into 5 is equal to 3750 rpm. Then we know specific speed ns is equal to, from the previous equation, n root over p divided by h power 5 by 4. So by comparing prototype and model, we get so nm root over pm divided by hm power 5 by 4 is equal to np over power of p divided by hp power 5 by 4. So given nm is 3750, and power of model we have to calculate it, and hm is 15 power 5 by 4 is equal to np given 1500 rpm, and power of prototype is 500 kilowatt, and hp given 60 5 by 4. So after calculating, we get power of model is equal to 2.5 kilowatt. So option D is the correct answer. That's to conclude the paper 2 of 2015. Next, thank you.